Okay, so this is where we ended the first part of the video with respect to goal programming. So let's now look into the second method that we have available to do goal programming. Recall that for the first method, that was the weight method, we asked the client to give us a hint of how much it would hurt him if one goal was not fulfilled. For instance, here we had in the objective coefficients that for underscoring or for not reaching the required 40 million of high-income men, the penalty for underscoring this would be $200,000. And so forth. For here, for not meeting or for not reaching enough low-income people, the penalty was $100,000, and so forth. So now, if, for instance, if our decision maker has a problem to really define those weights, so how important these weights are with respect to other goals, sorry. Then we can apply another method that is called the preemptive method, where the decision maker prioritizes the goals in relation to his subjective importance. So if the company, the customer of Burnit Advertisement prioritizes the goal to meet high-income people, then this goal would have the highest importance and the highest priority, and so forth. So here we ask the client to do some kind of sorting to tell us how, or ranking, to tell us how important the goals are with respect to others. So here, for instance, we can see that the first goal is of highest importance, then comes the second goal, and then come all the other goals. So here we introduce a deviational variable for those goals. I wouldn't use the name weight at that stage, but it's a kind of a ranking. In order to solve now the preemptive goal programming method, we can do this by applying the Simplex algorithm, but we need to prepare our objective function for that purpose. Here we will look shortly on the tabloid version of the goal programming Simplex algorithm, and then we go straight into how to implement this in AMPL. So this is what this video is about. So now as I said, for setting up the tabloid for the Simplex algorithm, we must decompose our objective into n components depending on how many goals we have. Here, for our example, we have 3 goals, so we need to decompose the objective term or function term with respect to our goals in order to give the ranking. This is how it looks like for the Burnit advertisement. So here we have now the objective function decomposed in our 3 components for the goals, for the 3 goals that we have. And this is the usual or the previous LP that or goal programming linear program, where we have the deviational variables given and the equations for our constraints. Here, this example is without imposing the modification that we cannot meet the budget constraint, but we will also look at how to implement this then in AMPL. It's just one piece more. So let's shortly look into how to apply the goal programming Simplex algorithm. We need to prepare, as I said, the objective function accordingly. So we need to decompose our objective function into the different components. So, for instance, the first version for the objective function is P1 multiplied by, and this is now the deviational variable for not meeting, for not reaching enough high income men. The second one is then with the second order to not reach enough low income people and so forth. So I want to show you shortly how to add now our row 0 to it. You recall from the normal linear program for the simplex that we called the objective function row 0, where we had our objective function put into the tablet, and now we need to add 3 rows because we have 3 goals. And I want to show you shortly how you arrive to this first row. For that purpose, we take the whiteboard, and I show you how you can rearrange the terms so that you can set that up. Recall that now I need some space. The first goal is zeta1, and it is given with P1 multiplied by S1 minus. If we rearrange those terms now to put it as row 0 in the tablet, and this is just the example for one goal, so you need to do this for all 3 goals. Then if you rearrange the terms, you get for row 0 zeta1 minus P1 multiplied by S1 minus, and this equals 0. The constraint for our first goal was 7x1 plus 3x2. You recall that from our task, plus S1 minus S1 plus, and that was equal to 40. And that was we call this the HIM goal, so reaching high income men. Now in order to put this into the order we need for our row, we want to rearrange the terms so that we can put the objective or the constraint in. So what we do is we sort this differently. We put all the terms that we don't need here on the right hand side. So this goes minus 7x, and this we do of course for both sides, minus 3x2, and for both sides plus S1 plus. So afterwards, after rearranging, S1 equals to 40 minus 7x1 minus 3x2 plus S1 plus. So now we can put this in zeta1, and this becomes then I do that in the long version, 40 minus 7x1 minus 3x2 plus S1 plus, and if we rearrange the terms, then this becomes x1, P1 multiplied by 40 minus 7 x1 multiplied by P1. We have to do this, of course, for all terms. This is P1 S1 plus. So I just lost the bracket, and for reasons that will become clear in a second, I rearrange the terms a little bit. So this is I want to be consequent, so I rearrange them a little bit better. So this is 7p1x1 minus 3p1x2 plus p1s1 plus, and now the last term is p1 multiplied by 40. Yeah, or we want to be even better, then we rearrange these two as well. So what we have seen here is that we want to put our objective function in this version for defining our row 0 for the tabloid. So this is zeta 1 minus p1. I just reproduce this so you can have a better look how we do this. So this is what we have above here already given, and now we put that in the row, so it becomes zeta 1 and now plus, because here is a minus, plus 7p1x1 minus minus is plus, so we have 3p1x2 and minus p1s1 plus and minus 40p1, and that equals 0. And now the last thing that I do is I rearrange these terms here to put it in the tabloid, and then the whole thing for our row 0 becomes as follows. This remains the same. x2, sorry. This also remains the same, and now here I rearrange to put in zeta 1 equals minus, well, no, it's not minus anymore because I rearrange it, so I put it on the other side, and then it becomes 40p1. Yeah, and this is our row 0. And if we go now back to the lecture slide, then you will see and realize that this is, for the first goal, the him constraint, exactly the terms put in the first row. And this is why I rearranged a little bit the terms. Okay, so how the simplex algorithm for the goal programming works now is similar to the normal simplex algorithm. So the first thing that we want to do is we want to find out which variable is the entering variable and the basic feasible solution. And for the purpose, we look at the highest priority goal now. We find the highest coefficient in that row now, and if we look at these two, they are positive, and the coefficient for x1 is higher than that one of x2, so this one lets us go closer and more rapidly closer to meeting our goal. So we select the x1 as the entering variable. Now we would perform the minimum ratio test for all rows to find out which constraint is binding first. If we do so, then we will see that the constraint for the high income man is the first binding. So we take this one as the pivot element. The rest is standard. We use Gauss elimination to produce here for the x1 in this column zeros. And if we do so, we can look at the first tabloid after this work has been done. We look at x1 and at our pivot element. Here we still have the 1 standing, and here we have produced by Gauss elimination zeros. And we see that the first goal is met, meaning that we meet the goal. That means that the highest goal reaches the high income or enough high income men that were required by the company. Now we proceed to look at the second highest goal, and we do exactly the same. We look at the coefficients and select the one that is highest of both of them in our case, and that is the S1 plus with 10 divided by 7. And then we do the minimum ratio test for all our rows. And if you do so, then you will realize that 2 constraints are equally binding. It's the low income people constraint and the budget constraint. So in this tabloid, you can choose which one or which way to go. And here it is chosen to select the budget constraint as the one with the pivot element. Yeah, when you perform the calculation, and you can do this by hand, it takes some time and it's quite tedious, but it's a good exercise for the brain. Then you will come after a while to the optimal tabloid, and here you will see that here we have produced zeros. You see the pivot element for the budget constraint. And you will also see that for the second highest goal now, this is 0, meaning that this goal has been met. If you look at the third goal, that was to reach enough high-income women, or the amount of 34.5 million women, then you will realize that this goal is not met. And that was also what we have seen in the Excel solution and also in the AMPL solution, that high-income women are not, the goal is not met by 5 million women. So if you look at the solution, the company will purchase 6 minutes of football advertisement and no minutes of soap opera advertisement. And the first goals are met, but the company falls short of reaching the 5 more million required high-income women. So that is for the solution. Now the question is, how can we implement the goal programming simplex algorithm in AMPL and find a solution for it? And with the knowledge that you have already gained so far in AMPL, you can absolutely do it. So let's go and look at the AMPL version of this exercise that we have already produced. And now I'm concentrating on the one where we don't include the modification for the budget constraint, but you can also do the preemptive method, of course, for the modified version. But I just show it here now to you for the easy one, and then you can modify it on your own for the other one. So one thing, we don't need anymore the penalties, because now we have given priorities, and that means that we need to modify also our objective now. So I leave it, but I exclude it, and now we can go goal by goal. So our new objective function is to minimize the function zeta, where the first goal needs to be minimized. So that was that we want to have the S1 minus S0, and yeah, that is all that we need right now. So we can set now the goal one by one to minimize first the S1 minus, then the S2 minus, and then we look at the third goal also, that was S3 minus. So we can do it one by one. You can also do it, but I want to skip that steps and go directly to minimize the third goal. And now we need to add some constraint to our model. So we add a C5 that says now that S1, that is the deviational variable for not reaching enough high-income men, you recall. The S1 minus needs to be now 0, because that means that we have fulfilled the goal. I add this also for the second goal. I can do this, of course, now because I know the solution. If you do it for a task where you don't know the solution, then you should do it for each and every step. But now I want to speed up a little bit. So that is all that we need here as a modification. Everything else can stay the same. So these are the two parts that we have modified. And now we say GP0 mod. And then you will realize that we get the solution for it. So we see now that here our third goal to minimize the S3 minus is 5. So that were the 5 million high-income women that we do not reach. And you see that we purchase 6 minutes of football game ads and no of soap opera advertisements. And you see also for the S3 minus that we have these 5 million high-income women. Yeah, so that is how you can realize implement the preemptive method in AMPL. And that was it. So thanks for watching, and see you for the next video.